This is Cameron Chai from AZOM.com, and I'm speaking to George Collins, who's the CEO of CAST. How are you doing today, George?
I'm very well, thanks.
Good to hear. So tell us, what is CAST and where has CAST come from?
Okay, CAST is what we call a cooperative research centre. It's a cooperative research centre working in the areas of metals manufacturing. We're made up of participants who are either from industry or from the research sector who work together on industry-driven projects. So we're made up of companies and universities and the CSIRO around Australia. Our activities stretch from Geelong to Gladstone.
Okay, and when was CAST established?
In its first round, CAST was established way back in 1993, but in its current form, with its current set of members, with its current projects in 2005. So we've been going just 4 years on these set of projects with these companies.
And what sort of projects are you working on?
They cover a range of things. Traditionally, CAST works in light metals, in magnesium, aluminium, but we've extended recently to titanium and into ferrous metals too. So in the magnesium portfolio, it's originally directed on alloy development, say for powertrain and structural applications in automotive. In the general processing area, we work on developing new methods for ingot casting, for improving processes within general in casting. We work in extending these days into other applications such as defence. That's where titanium comes in, the machining of titanium, but also into materials for extreme environments where high wear, high corrosion occurs. And we also have a whole lot of projects smaller projects directed towards the needs of small and medium enterprises, where we're really bringing in technologies. It's a mixture of best practice and technology diffusion.
Okay, and why are light metals so important for anybody who might not be all that familiar with them? Why is all this research needed? I mean, steels and things like that have been around for decades, and people, the industry knows how to make things out of metal. Why does an organisation like yours exist to help promote these light metals?
I guess for two reasons. One, they're light, so they offer potential for significant light weighting and savings in mass. They also, for Australia, Australia has large resources in aluminium and particularly in titanium and interest in magnesium. But so for our country, it's important that we establish uses and new applications, new processes for using these materials, which complement steel, and steel's a great material. But in some places, in aircraft, for example, in lightweighting automobiles, and of course we all know the thousands of applications that aluminium already has in our society. So opening up for these metals and making their processing more efficient, and that, in the end, that means reducing the costs in turning, from the oxide into a metal product. And along the way, you've got to, after you refine, you smelt, and then all sorts of manufacturing processes, forming and forging and die casting or whatever. So we're working right across that value chain, and our industry participants really follow that value chain from the production of the metal right through to a final product.
And can you tell us about some success that you've had already with the project?
We've got a number of our alloys, say for the magnesium alloy, which have been successfully trialled. For example, a high creep resistant alloy that has been in an engine block in vehicles and trialled significant times and how they work. We've now got that was originally a sand cast alloy. Now we've got a high pressure die casting version of that. We have an extrusion alloy, and that really, for a magnesium alloy, extrudes just as well as aluminium, so that opens a whole lot of things. And so through our partners, and what happens, we license our technologies to our partners who then commercialise and offer them on the market. We are promoting those. In terms of casting, and for example in ingot casting, we developed some new processes for ingot casting which are now combined into machines which are in use here in Australia, but also now available throughout the world, and one of our participants has been exporting equipment based on that technology. In titanium machining, we've developed improved methods and reduced the time. Titanium is incredibly difficult to machine, and we've reduced the time it takes to machine that, and now developing new technologies to make machining of titanium easier, because traditionally people say it takes 10 kilograms of titanium to turn 1 kilogram of an item, and there's a lot of work getting rid of that other 9 kilograms, and so we're trying to make the machining of titanium easier. So they're just some examples, and of course within individual companies There's examples of where we've done projects to help them in a range of things, whether it be in reducing their CO2 emissions, improving their processes and productivity, getting up to best practice, looking at energy consumption. And so there's a range of things that we do, not beyond just the dealing with the metal, but the things that go around it.
Right. Oh, well, that sounds like at least we can see there's some good benefits that have come out of these government-funded projects for anybody who sits there cynically and wonders where all this taxpayer money goes and this government money goes.
Yeah, with our system, it's co-investment though between the government money and the companies themselves, and even the research providers are putting some of their own resources into these projects. So yeah, it's a mixture of funding, and it's really a partnership, a collaboration, a co-investment model. People say it's an example of public-private partnerships.
Oh, well, that's good that you've got the cooperation going there. All right, George, thanks very much for telling us about the CAST project, and we wish you every success with it.
Good. Thanks, Dazon.
Thank you.